Good afternoon and welcome to NASA's Johnson Space Center in Houston, Texas. I'm Sandra Jones and we are here today to discuss an upcoming spacewalk outside the International Space Station slated for Tuesday to repair a joint on the Canadarm2. Here today to discuss the upcoming spacewalk, we have briefers from both NASA and the Canadian Space Agency. Joining us today, we have Bill Spetch, Operations Integration Manager for the International Space Station, Fiona Antkowiak, Spacewalk Flight Director here at NASA Johnson, and Jason Dyer, the Deputy Liaison Manager for the Canadian Space Agency. We'll start with some opening remarks from each of our briefers before we get to questions both on our phone bridge and here in the room. If you are on the phone bridge, you can press *1 to submit your name into the queue. Once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. So without further ado, I'll toss it over to Bill for his opening remarks.
All right, thank you. And thank you everyone for joining us today to discuss this next spacewalk outside the International Space Station. So during nominal operations of the Canadarm2 last month on May 27th, we observed that the arm showed an elevated motor current and did not move as expected. The arm was then placed into a safe configuration while we worked on some analysis to see the situation we were in. We worked alongside CSA to understand the issue and determined that a spacewalk was required to replace the joint using a spare already on board the International Space Station. Systems like Canadarm2 were designed from the beginning with replaceable components and were planned with maintenance in mind, and this is no exception. So NASA astronauts Chris Williams and Jessica Meir will exit the station's Quest airlock to replace the joint. This spacewalk will be the second for Chris and the fifth for Jessica. It will be the 280th overall spacewalk in support of the space station assembly, maintenance, and upgrades. In other space station operations, we're looking ahead to our next Soyuz rotation and crew swap next month. On July 14th, we will have the launch of Soyuz MS-29 from the Baikonur Cosmodrome in Kazakhstan. Crew will include Pyotr Dubrov, Anna Kikina, and Anil Menon. This will be the first flight for Anil, and we're looking forward to seeing him on station soon. And it will be the second flight for both Dubrov and Kikina. The docking will occur to the Prishal module on the Russian segment. Launch is scheduled for 14:47:54 GMT, or 9:47:54 Central Time, and is scheduled at approximately docking is scheduled at approximately 17:55:27 GMT, or 12:55 Central Time. On Space Station, the crew members are doing well and continuing their busy Increment 74 operations, which will conclude and become Increment 75 when Soyuz MS-28 undocks on July 26th. On Soyuz MS-28, NASA astronaut Chris Williams with Roscosmos cosmonauts Sergei Kuzhevchikov and Sergei Mikhaev will return. After that, within a week or two of that departure, we will start work on our next three spacewalks on the International Space Station. We will have the upcoming 3B solar array mod kit install. We have the EVA that we've coined as the triple jump EVA, which is doing a number of different jumpers on board, as well as our replacement of a faulty antenna outside the ISS that we use for communications called the SCANT. We'll have those, we'll talk more about those as we get closer to those actual spacewalks. With that, I'll hand it over to Fiona to discuss this upcoming spacewalk in a little bit more detail.
Thanks, Bill. Good afternoon, all, and thanks for the interest in our spacewalk. As Bill mentioned, our two spacewalkers will be Chris Williams and Jessica Meir. Chris will be EV1, and he'll be going outside with a red stripe on his suit. And Jessica will be EV2. She'll be going outside with an unmarked suit. From the inside of the space station, their crewmates Sophie Adeno and Jack Hathaway will be assisting them. Sophie and Jack will be critical for getting the crew into their spacesuits and out of their spacesuits, as well as supporting with some robotic arm motion as we make sure we're in the right configuration for our repair. Moving to the ground, we have a phenomenal team working on this EVA. I'm excited to be working with Canadian Space Agency astronaut Jenny Gibbons as our ground IV. She'll be speaking to Chris and Jessica during the spacewalk. And Japanese Space Agency astronaut Aki Hoshide will be our Capcom, talking to the crew inside the space station. Our EVA team is led by Farouk Sabur, and he has a great team working with him to make sure that we have a safe and successful spacewalk for our repair. I'll dive a little bit into what we're doing on our spacewalk now on the next graphic. As was mentioned, we are replacing a joint on the robotic arm. The sequence of events that we need to do that: first, we will get the spare joint that Bill mentioned is already on the space station ready to go. It's on a temporary stow location right now. We'll move it because we need that location a little bit later and get it in the right configuration for install. Then we'll remove the latching end effector, or the Lee, plus 2 working joints from the end of the robotic arm. The purpose of that is to access the failed joint. So that cluster, or Lee plus 2 joints, we will temporarily stow in the location we took the spare joint off of. That gives us access to joint 5, which is the one we're replacing. We'll remove the failed joint 5, replace it with the spare joint, which will be our new joint 5. And then once that's back on the arm, our last major task will be to get that Lee cluster that we temporarily stowed and put it back onto the robotic arm so that we have a fully assembled arm at the end of the spacewalk. We do expect this series of tasks to take about 6.5 hours. So it is a full spacewalk. Our typically scheduled time will all be spent working on the robotic arm. And lastly, the spare joint, excuse me, the failed joint that the crew removed, they'll bring it back inside the space station. That allows us to get it back down to Earth and begin both investigating it and refurbishing it for future use. Because we're working really on one task, the crew spends their entire day at what we call ESP2. That's one of our support platforms outside the space station. It's not very far from the airlock, so it'll be a pretty quick first translation out there and then return to the airlock. So this graphic shows the configuration that the work site will be in. You'll see that we have our 2 crew members. They're in foot restraints on either side of the robotic arm. That failed joint is called out, so you can see the Lee cluster is kind of the part to the left of that in the image. We'll take that off, put it where the spare joint currently is, and then change out that joint that's in the red circle on the bottom right. The crew will be getting in and out of this position and kind of going around that platform as needed as they manipulate the joints, but really they spend their whole day in this general area of the space station. And we're looking forward to returning a fully functional arm at the end of the spacewalk. So with that, I'll jump into an animation and we'll kind of walk through the spacewalk in slightly more detail. Okay, so our crew members start the day by exiting the airlock. As mentioned, they'll then go to that work site that's quite close by. So Chris just goes around directly there. Jessica has to go up on a little bit of a longer path. The reason for that is to grab the foot restraint that she'll use for the day. So she'll go up to what we call our port CETA cart. She will get that foot restraint, and then she will meet Chris basically on the other side of that work site. The crew will set up the foot restraints, and then they'll remove the spare joint from its storage location. As I mentioned, that allows space for the Lee cluster, and we'll place that spare joint on a temporary stow location that you'll see up on the right of your screen here. That makes it accessible for later. Once that's done, the crew will get in position in those foot restraints that they've set up, and we will actually bring the robotic arm in to their workspace. So this is one of the things Jack and Sophie will be helping with from inside. You'll see that robotic arm is gonna pitch down so that the crew can access it. At this point, before we power it down, we'll have the crew confirm good access to all the fasteners that they need to use throughout the day. So what they're doing here is just using their tools to make sure they can get to all of those fasteners. Once that's done and we've powered the arm down, they can begin the disassembly. And so as I mentioned, the first thing they'll have to remove is that end effector plus 2 joints. There'll be an electrical fastener they'll undo, and then they'll undo 6 structural fasteners. That will allow them to remove that cluster from the arm. And once that's done, they will be moving it to its temporary stow location where we just took the spare joint off of. That whole cluster then stays there for the rest of the spacewalk. And so we make sure that it's fully in place and secured with the required number of fasteners to be in a good configuration to hang out there for a few hours while we work on the failed joint. So once that's in that configuration, the crew will head back to the arm. They'll remove the failed joint 5, and one of the crew members will temporarily put that attached to themselves, kind of out of the way. They'll then grab the new joint that we had temporarily stowed and reinstall that. So this puts our new spare joint in place of the previous joint 5. We'll get the failed joint out of the way, and then the crew will go back to working on that Lee cluster, where they will be removing it from its temporary stow location and then getting it back on the robotic arm. As you can see, I mentioned the crew members do get in and out of those foot restraints. It's one work site, but you still have to make sure you can reach everything, and so they'll be in and out of those foot restraints and also changing the positions as needed. So they'll remove that Lee cluster from its temp stow location. They will then get back in position to rotate it and get it back onto the robotic arm. And their last major task for the day before they clean up is shown right here, where they reinstall that cluster onto the robotic arm. They will re-engage all of the structural fasteners as well as the electrical connectors. And in that configuration, we'll be ready for Jack and Sophie to work with the ground. We'll power up the arm and make sure that we have an electrical connection to the entire arm. While we're doing that, Chris and Jessica will head back to the airlock. We won't be moving the arm before they come inside, but we will verify that we have good electrical connectors. Like I mentioned, that's expected to take the full 6.5 hours, and so that will be our day on Tuesday. And hopefully at the end of the day, we have a fully functional arm ready to support all of our operations. So with that, I'll pass it off to Jason.
Well, good afternoon, and thank you for having me here to discuss the repair of our Canadarm2. Give you a brief overview. It was launched in April 2001, and Canadarm, as previously mentioned, has been an integral part of the International Space Station. It has 2 end effectors, or hands, along with 7 joints, and that allows it to walk itself through multiple positions on the International Space Station. With that type of flexibility, Canadarm2 has helped with the assembly of the space station, supported numerous spacewalks, helped or captured and berthed over 50 visiting vehicles for cargo, and installed and relocated science experiments all over the external part of the space station. In addition, with its partner Dexter, our 2-handed robot, the Canadarm2 has replaced several pieces of equipment outside that would otherwise require a spacewalk. Canadarm2 was originally designed for 15 years of use, but as the space station exceeded expectations, so did the Canadarm. Now, just passing 25 years of use, it's aging gracefully and it's showing signs of wear. However, this graceful aging was always part of the original design. The Canadian Space Agency and its partner McDonnell Detweiler and Associates designed these joints and the end effectors to be replaced. We saw this back in 2017, 2018, where we replaced both hands on the SSRMS. And now it's time for one of those joints. As mentioned before, we have joints and spare hands on board. And while this spacewalk will use up one of those joints, we do have another joint and end effector or hand on the ground being processed for launch. Canadarm2 continues to be an integral part of the space station, and the Canadian Space Agency would like to extend our thanks to our international partners, and specifically to the EVA and robotic teams led by Fiona here on their quick response to developing this spacewalk to fix our Canadarm2.
Thank you to our briefers for those opening remarks. We will now open it up for questions on the phone bridge. We do have several folks dialed in, so please try to limit your question to just one at this time. And if you do want to join the queue, you can press *1 to get your name submitted. Our first question will be from Will Robinson-Smith with Spaceflight Now.
Hi, thanks so much for taking the time to talk with us today. Question for Bill Spetch. Earlier this week, we heard from the ASAP committee, and the chair mentioned her discussions of the ISS program that the panel had been, quote, tracking the status of EMU hardware and that supply chain issues have exacerbated the EMU risks due to aging hardware, although there is a robust life extension plan, end quote. Can you talk about the status of the supply chain for the EMUs and what the life extension plan looks like at this date? Thank you.
Yeah. So as these as you know, our spacesuits have been with us for a very long time. And with everything, they were made modular so that we could replace components, we can refurbish components, and we continue to monitor that. We have 4 great suits on board right now, and we actually have our next one that is coming up in the rotation that's going to be launching this fall. So from a standpoint of that, I think we're in great shape right now for where our suits are, and we continue to work very closely with the team that maintains those suits to address anything that we see coming. But as in the near term, we're in very good shape on the suits, and we have 4 good ones on board.
Thank you. Our next question will be from Marcia Dunn with the AP.
Hello, Bill, another question for you, if I might. Could you please provide an update on the leak situation on the Russian side? And I'm also wondering, is the Dragon capsule rigged up right now to carry 5 astronauts in case of an emergency? And I ask this because Chris joined the SpaceX crew in the Dragon earlier this month for temporary safe haven. Thanks a lot.
Sure. So as of right now, the PRK section, it is not experiencing a leak. It's actually at a stable pressure. We've reduced it on purpose down to a lower pressure, working closely with our Roscosmos colleagues on the plan forward on that. In terms of the Dragon setup, yes, it is set up with a 5th seat installed. We've left it in that configuration for most of its stay on ISS at this point.
Our next question in the queue is from Bill Harwood with CBS News.
I'm not sure if this is for Jason or Bill, but I'm confused about the number of joints on board station right now after this EVA. I was confused if the one you're going to launch soon. In other words, just how many are on board and how many are getting ready to launch. And for Bill, long-range plan was if you're going to retire the station in 2030, assuming that's the case, does the arm need to be fully functional all the way to the end? In other words, if you ran into some problems down the road, would there come some point where you just say, we're not going to try to fix it? Yeah. If you see what I'm asking.
Do the first part of the thing?
You want to
I'll start with the easy one.
Yeah.
So currently there are 2 joints on board ready for use if needed. We are going to use one of those, and we'll leave one up there if there happens to be a need for it later on. The one that's being the one that's being replaced, as it was previously mentioned, is going to come down, and we'll start the process of getting that turned around to go back up. On the ground, we have another spare joint that's in work, as well as a spare hand. And as those complete, we'll get them in the queue to be launched and brought back to the ISS.
Yeah, and to the second part, the arm is critical to everything that we do on ISS. So whether it be capturing cargo vehicles like Cygnus, doing maintenance outside of the station, it actually becomes critical even when the crew leaves to help us maintain items on the space station as we get ready for deorbit. So there's not a time where we go say, hey, we're just done repairing the arm. Are there components within it that we may assess if a camera is available or not? Yeah, that kind of thing might be discussed. But overall, the arm is critical for station operations and continued maintenance of it through to the end of life.
Thank you both. Next up, we have Ryan Catan with NASAspaceflight.com.
Hey, thanks for your time. I was just wondering if there's any other issues you're tracking with, or maybe not issues, but potential issues with aging parts you're tracking with the arm, and if they would require an EVA. And I was also wondering if, in the event that the arm is unavailable for an extended period, if NASA has any contingency plans in place of how you can operate station without the arm. And I'm wondering if you do have them, if you could share what those are. Thanks.
Sure. I'm not tracking any other areas of concern on the arm at this point in time in terms of that. We watch it very closely, all of the various joints, how they perform, all the various systems within the arm and how they are performing over time. And I'll let Jason add anything that he needs to on that. I'm sorry, repeat the second half of that question. Make sure I've got it.
Yeah, if the arm is unavailable for whatever reason for an extended period, does NASA have a contingency plan of how to operate station without the arm, considering, as you said, it's very important for getting the cargo on and such? And if there is a contingency plan, could you share what that plan is?
Sure. I mean, so this is a reason we maintain spares on board for all of these components, right? Jason talked about multiple joints on board, multiples of the latching end effector or the hands for the arm. The critical components and this is not just the arm itself, but across the ISS, we maintain sparing on board and our capability to go out and do a spacewalk to go repair those things that are outside. If the arm were down for an extended period of time, it does interrupt cargo resupply in terms of what we can do from a Cygnus standpoint, but we have Dragon still available that docks to the vehicle and does not require the robotic arm to deliver supplies. Now, there are other components that outside we cannot maintain without the help of the arm. So we have a number of critical components that we need to be able to use the arm to do the repairs on. But there are many components that we don't need the arm for. And we can just go out and do a spacewalk to replace those components if needed. But ultimately, the arm is critical to what we do, and we maintain sparing accordingly so that we can recover it in the right amount of time to keep going.
And as a reminder, you can press *1 to submit your name into the queue if you'd like to ask a question or have a follow-up. We do have a couple of questions from social media, so I did want to address that. This question is, how do astronauts train beforehand for a spacewalk?
Yep, I can take that one. So here on Earth, the astronauts use what's called the Neutral Buoyancy Laboratory. It's a very large pool that they can use to float or be neutrally buoyant. That lets them feel as close as we can get to what it feels like to float in space. So as part of their initial astronaut candidate training, and then again when they're training for their specific mission, they do about 10 runs each in the Neutral Buoyancy Lab. They practice kind of generic spacewalking tasks. So we might not know exactly what they're going to do, but we know the types of tasks they need to practice. So they get in their spacesuit, they go underwater, and they spend about 6 hours underwater practicing. And they also have some lessons in a mock-up of the airlock to learn what to do before and after. And then once we have a specific spacewalk for them, they have time while they're in space to study the procedures. They have tools on board that let them visualize, very similar actually to the animation I showed earlier, what they will do during the spacewalk. And so they use those tools as well as a robotic simulator to understand the specifics of that spacewalk and apply their training to the specific spacewalk.
Thank you. Next up, we have David Denault with About Space Today.
Thank you. I'd like to focus back on the question of the spacesuits. Help me here to understand, are these the same suits that were developed back in the 1970s? And when would we expect ever to have new suits at the ISS?
So that's a great question. So yes, these suits have been around for a long time. We used them during the shuttle program, and we continue to use them during the ISS. And we see using these through the end of ISS life. We are actually looking at demonstrating the next generation of suits that will be used as part of Artemis on the space station at a time where it makes sense for them. I think we're targeting probably sometime next year, but there's still some work to go on that. But we definitely have demonstrations planned for that. As folks are aware, they are developing a new suit for the moon.
We have a follow-up from Will Robinson-Smith with Spaceflight Now.
Hey, thank you, Sandra. Sort of a follow-up to the follow-up there. With the AXCMU suits that are being developed for the Artemis program, Axiom, I believe, also had a secondary contract with NASA to develop a version of the suit that would be designed to operate on board either the International Space Station or future commercial space stations. Would that iteration of the suit be ready for testing and be folded into use for a nominal spacewalk before the retirement of station? Thanks.
I think the focus for them right now is on the moon, and that is the complete focus of that team is to get that suit ready to go for the Artemis program. We're happy to help them with demonstrations where we need to and continue to do that, but their focus is really on development for the moon, and we're focusing on maintaining the EMUs through the remaining of ISS life.
And it looks like our last question will be from Bill Harwood with CBS News.
Yeah, hi. This is just a really nuts and bolts question for Fiona, I think. Do you have any idea what that joint would weigh if it was down here on Earth? Want to get a sense of the mass of the things.
Yeah, the Joint 5 that we're replacing is just over 200 pounds. The Lee cluster, so the end effector plus the two joints that the crew will temporarily move, is just over 900 pounds.
Thank you to our briefers, and thank you to all of the media, as well as those on social media who did submit questions today. We will be covering the entire Spacewalk live beginning at 6 a.m. Central on NASA Plus, Amazon Prime, Netflix, and the agency's YouTube channel. So we do hope you'll tune in for that. But for us here, that'll do it for us today. Thanks so much for joining us.